Welcome to August 8th LeetCode challenge, rank transform of a matrix. Given an m by n matrix, return a new matrix answer where answer at row and column is the rank of the matrix row column. The rank is an integer that represents how large an element is compared to other elements. It is calculated using the following rules. The rank of an integer starting from 1. If two elements P and Q are the same row or column, then if P is less than Q, then the rank of P is less than the rank of Q. If P is equal to Q, then the rank of P is equal to the rank of Q. If P is greater than Q, then the rank of P is greater than the rank of Q. The rank should be as small as possible. It is guaranteed that the answer is unique under the given rules. Okay. So we have a matrix here, 1, 2, 3, 4, and our output is going to be 1, 2, 2, 3. So basically, at matrix at, let's say 0, 0, which is number 1, it is the smallest integer in its row and column. So therefore, we return the rank of 1. Let's see, the rank of the matrix at position 0, 1 is, let's say 0, 1 is 2 here. And we know that the answer is 2 because the matrix at position 0, 1 is greater than 0, 0, and 0, 0 is at rank 1. So therefore, the rank is 1 higher than the 1, 1. Likewise, going below as well, the number 3 is larger than 0, 0, and also is greater than rank 1. So therefore, the rank must be 2. Likewise, following that same pattern, we have the rank of position 1, 1, the number is 4 because number 4 is larger than 2, number 4 is larger than 3, and we recall that the rank of 2 and 3 are 2, so therefore the rank has to be 3, which is higher than 2. So that's kind of the method to solve it. If the rank of the matrix has all the same integer in each of the columns and rows, and all the cells, I should say, then all the rank is equal to each other. And this one's a bit tough here, but if you go through the same scenario here, then you know that the rank and of all this will be, the final output will be that. And you just kind of work your way going across. And here's another example here. So let's see, the length of the matrix M, the columns are N, M is greater or equal to M, and then N is less than or equal to 500. Let's see some of the hints. Sort by the cell, process by increasing order, that makes sense. Rank of cells, rank min, maximum rank of rows, column plus 1, yep. Handle the equal cells, treating them as unifying data structure. Alright, so this is a hard question here. So the first thing, I guess following the hint here, your unifying data structure, I'm going to be using a disjoint set union solution, and I'm going to use I'm going to define basically a find function for it as well. So first, let's set up our matrix and kind of analyze that. Right, our setup. So first, we're going to find the rows and columns of it. So we're going to find n by n, and that's going to be the length of the matrix. And then the row is going to be the length of the matrix at index I, or index 0, I should say. Index 0. Alright, now that we have our length and width, our m by n, next we need to find a matrix called answer, which is the output basically. Answer, and that's going to be the list. We're going to make it basically a matrix out of it using list comprehension. Everything initialized to 0 first, so has 0 in there. Star n for cell in matrix. So we make a new matrix, everything populated with 0, and then we're going to have to find we're going to make some rows and columns as well to populate it. So rows, columns, and that's going to be 0 times m, and then 0 times n times n. Alright, that's our initial setup. So now we have our answer, we have our n by n matrix, and we have rows and we have columns. Let's see. I'm going to be using disjoint set union solution. So I'm going to first define the find function for it. So we're going to basically develop that. So we're going to define, we're first going to initialize a default dict called parent. And it's going to take an dict dictionary, and disjoint set union function find function is going to be defined as definition of find, and it's going to take in a value and x. Let's see, if x is not equal to the parent value, dot set default to be x. So if that's the case, what we're going to do is reassign the parent value at x to be it's going to be a recursive call to itself, so find the value at the parent value at x. Alright, that should, and then we want to return the parent value at x. Alright, now that we have defined our disjoint set union find function, this is what it does. It's a recursive function that basically we're looking for the or finding the parent value at x. And next thing we want to do is define the disjoint set union process, I should say, process for it. So how that works is, if you're not familiar with the disjoint set union type function data structure, neither am I. I mean, you just know well enough to define it. For I, j, and the product of the range of m and range n. Yep, so basically we're cycling through the product of the range times the range of n times nm. And what we're going to do is update the value. So value is going to be matrix at ij, which is the cell. J, and then we want to basically find the parent at the value at find val at x. No, I should say. And square product, and assign that to be find value of val g's. J. Alright, next thing I want to do is group together if the values are similar on the same connected group of coordinates. So we want to define something called elements, default dict. We'll use a lambda value function here. Default dict set And then we're gonna do a for loop this for I and j and the product of range mn, range n. What we want to do is we want to update the value to be the matrix at ij position. So it's very similar to the first set of code in the front and above it. And then we want to reassign elements at the value location to be find val at I dot add. We're adding the tuple I, j to it. Alright. J. Now is we're assign the rank. So for the value v in sorted elements, for group in the element at v, which is the value, dot find the values. We want to find the n rank, which is the max of the max between rows I and columns j. Let's see, max again, max, yes. Oh, it's let's see, for I, j in group +1, right? For I, j in group rows I will be assigned to n rank, columns j will be assigned to n rank, and then our answer at I, j should be n rank. And then at the end of all this, we want to return our answer. Hopefully this works. Let's submit it. Okay, accepted. So this obviously is a very tough question. So we did use most of the hints actually. So sort the cells, right? Which we did here, sort. Recall that the cell of rank, medium rank, row and column is +1, which is right here. And then we did use the equal cells by treating them as union find data structure. We did use a data structure union find for these two. Then we initialized it. So it's pretty much all the hints and everything, and even all the beginning type of clues that are given in the beginning. It's just very tough to land this one together. It's also very bulky and very messy as well. But there you go. Space time complexity is basically big O of let's see, big O of n times m log of n times n. So big O of log mn log mn. And then space complexity will take it's, oh geez. So the find function is let's see. Yeah, it's the space complexity is basically storing it in the answer, but we also have this disjoint union set return value here, which also stores the value. So it's it might be, I think has to rely on maybe the inverse Ackermann functions. but because the disjoint set union takes time complexity is it's very hard to understand, very complicated, beyond the scope. But yeah, I'm not even gonna try eyeball it either. Otherwise, yeah, have a great day, guys.